triangle congruency proofs. These proofs are going to be similar to what we've done before. So when you do this, you want to fill in one given at a time. I like to write each given in its own line for these because each time you write down a given, you have to mark the figure for each step. So that's really important and a little different than what we've done before. If the proof is incomplete after you've used each given, you're going to look if any vocabulary terms are present in the diagram. So specifically today, we're going to be looking for vertical angles or the reflexive property. And then after each box is filled in, you want to look at your marked diagram to determine which triangle congruency proof or shortcut we use. So that's either going to be side, 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 angle, 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 side, or HL. Says given AB is congruent to QS. So you want to start by writing that down under statement. And then you write the word given for your reason, and you want to go mark the diagram. So again, these are sides. Sides get those tick marks, so it would look like this. My second given says AC is congruent to QR. So same thing, I'm going to write that under statements. I'm going to write the word given for the reason. And then I want to go up and mark my figure. When I mark my second side, I want to mark with 2 congruency marks instead of just 1. And then my third given, BC is congruent to SR. That is also given. This time it's the third side I'm marking, so I do 3 tick marks. And when I look at my diagram, I know it's complete because each triangle has either 3 sides or 3 angles marked or a combination of those two. And then I can write down what they're asking me to prove, which is that triangle ABC is congruent to triangle QSR. And I know that those two are congruent because I marked 3 sides in each triangle. So this is side, side, side. The second example is very similar. So I'm going to start by writing down the given statements. So the first one is AB is congruent to QS, and the reason is given. AB and QS are sides, so I mark right in the middle of the side with a single tick mark. My second given says angle A is congruent to angle Q. That's also a given. Since this is the first angle I'm marking, I can mark with the arc mark. So A and Q are both going to get one single arc mark. My third given is angle QSR is congruent to angle ABC. This is also a given. Again, if you're a person that's struggling with when angles are named with 3 letters, think about if you took a highlighter and outlined it. So if I start at Q and then go to S and then go to R, you can see that the angle outlined in red, the corner is right here at S, so I'm going to double mark it. You can also notice that S is the middle letter. The vertex is always the middle letter. So that's really where my mark is always going to go. So for the second one, angle ABC, I know that B is the vertex, so the mark goes in angle B, and it gets a double mark. Again, once you look at your diagram, I have 3 things marked in each figure, so that's angles and sides combined. So I have these triangles are congruent. If you're still struggling with which shortcut was used, kind of ask yourself how many sides and how many angles did I mark? So I marked 2 angles and 1 side. So the next thing you need to figure out is what order do those need to go in? So my choices are angle, side, angle, or angle, angle, side. And really the difference is the side right in between the 2 angles? And if you look, it is right here. It's right in the middle of those 2 angles. So this would be angle, side, angle. On this example, we're going to start really similar with AB is congruent to QS. That's our given. Those are sides. So we're going to mark those sides with 1 tick mark each. My second given is AC is congruent to QR. And that's also given. It's my second side, so it gets a double mark. And the diagram already started with an angle marked, and so I have actually finished this proof, and I can write down triangle ABC is congruent to triangle QSR. When you try to figure out what shortcut you've used, it looks like I have two sides in an angle, and the order is really side-side angle, which we're not allowed to use. But don't forget, if you have a right angle and you mark the hypotenuse and a leg, it's actually HL. So don't forget to always double check that when you have a right angle. On this example, very similar. So start off by writing whatever you're given. So XY is congruent to XZ. The reason is given. You mark your figure. So here's XY, here's XZ. Those sides get 1 mark. The second given is YP is congruent to ZP. Again, that's given. And those sides, since they're the second side, get double marked. And then if you look, I'm out of givens and my triangle does not have enough marks for me to actually prove these two are congruent. But if you look at these two triangles, so here's the first triangle and then here's the second one. I am highlighting that middle line XP twice because it's shared by both triangles. So previously we talked about how that has to be the same length in both so we can mark it. Now we haven't talked about what you're going to write. So you're going to have to name it. So I'm going to name it XP. So XP is congruent to XP. And this property that we learned a while ago is called the reflexive property. Remember we talked about how it kind of sounds like reflection. You see yourself when you look in a mirror, while when XP looks in the mirror, XP sees itself. So if you have the same thing on both sides of the congruent sign, it's going to be reflexive. And to be totally correct, we'll write property of congruency because there's a congruency symbol in that statement. After I add that reflexive property, I now have 3 marks on both triangles, which means I can prove these two triangles are congruent. And when I look up at my diagram, I see that I have 3 sides marked in both, so this would be side, side, side. Very similar to the last one, so we're going to start by writing out our givens. So XY is congruent to PZ. We're going to mark our diagram. So XY, PZ both get 1 mark. The second statement is angle XYZ is congruent to angle PZY. Those are both my givens. I forgot to write down that first one. And so again, if you have trouble with these, outline with a highlighter or even your pencil, but XYZ is this angle. Now, just be careful when you're trying to mark the vertex because it's not the entire angle this time. It's not the entire angle at Y. It's just this little section. So this section here is XYZ. I'll highlight the other one in green. So PZY. Again, it's not the entire angle Z. It's just this small section here. So those are actually what I mark congruent. Then I'm out of givens, so I don't have anything else to mark. But if you look at these two triangles, they share this middle line, ZY. So I can mark that. It gets 2 marks because it's my second side. And then I can write ZY is congruent to itself, so congruent to ZY. And that is the reflexive property. And I'm just going to write POC. It's a property of congruence because in our statement we wrote a congruency symbol. And now we have our 3 marks on both triangles. So we know these triangles are congruent. And if you look, you have marked on, if I just look at this triangle here, I have 2 sides and 1 angle, and the angle is right in between those. So it's actually side, angle, side. And then this is our last example. I did have to make a quick correction. I realized I wrote a bad proof. So if you can correct yours to match what I have for my givens, I would really appreciate that. So the first statement should say IF is congruent to GF. Again, yours doesn't match that. So please fix it and then write it down and write the word given. And then we have to mark our picture. So IF and GF are both going to get 1 mark. Then I'm going to write down my second statement, which is EF is congruent to HF. That's another given. And since it's my second side, it gets double marked. And then this time I'm out of givens again, so I want to look at my diagram and see if there's anything I can mark. This time my triangles don't share a side, but I do see, since this is that bow tie picture, that they have these vertical angles we can mark. Now, it's very important on diagrams like this that you name the angles with 3 letters. And if you're having a hard time with that still, use that highlighter. So for this left side, I start at E, I go to F, and then I go to I. So this would be angle EFI. And that would be congruent to, I start at H, I go to F, I go to G. So angle HFG. You'll know if you're doing this right because since F is the vertex of both angles, F should be that middle letter. And then this is called formally the vertical angle theorem. So I like to abbreviate it like this, but you're welcome to just write vertical angles, just as long as I know what it is. After that, we have all the marks that we need. We have 3 on each triangle. So I can write that the triangles are congruent, which is what I was trying to prove. And if I look, I have 2 sides and an angle marked, and the angle is right between those sides. So this is side, angle, side.